In this video we are going to graph absolute value functions. Absolute value functions. So first we need to talk about a few background information things. In general, you're going to see an absolute value function in this form. Sometimes you might not see all of the variables, and we'll talk about what their value is if they're not shown. But these are all the variables that affect a graph in an absolute value function. So the A is going to represent our slope. It's going to affect the incline of the lines that we're graphing here. So if A is negative, or if A is less than 0, right? Then what's going to happen is our V, and we'll see that absolute value functions as a graph are V's. Our V is going to open downward, open down, right? And if A is positive or greater than 0, and that's going to be normal, and it's going to open up or open upward. This H value and K value are going to give us a location of, hold on a sec, give us the location of our vertex, or the tip of the V. And so it's going to be in an X, Y form, but I'm going to say H comma K just to be more clear. So whatever this number is right here, whatever this number for H is, that value is going to be written right there. So it gets a little confusing because this negative sign does not belong with the H when we put it in the coordinate pair form. So if this were a 3 right here, it would read X minus 3, right? But the vertex wouldn't be negative 3, it would just be 3. So we just take whatever H is, we don't include this negative with that H, and we just put that value of H down there. And then K, it's not necessarily so confusing. If it's a negative value, then K is going to be negative, and if it's a positive, then K is going to be positive. And we'll talk about that a little bit more when we get to it. And H values shift our vertex. They shift our vertex along the x-axis, and the K values shift our vertex up and down along the y-axis. So that's a little bit of background information based on the generic form of an absolute value function. Let's actually get into some examples now, though. Let's get a graph going here. Alright, so one example we can start off with is just the base form. Y equals the absolute value of x. This is called our base graph. And the more variables we add to this, the more it affects this base graph. And we'll talk about how they all affect it in just a second. So if we wanted to graph this, we could use an XY table. That might be one way we could do it, right? So if we give ourselves x values like 0, -1, -3, we can start to see what happens. So if I plug 0 in for x, the absolute value of 0, well, that gives us 0. So 0, 0 is going to be on our graph. And specifically, 0, 0 is going to be our vertex, and I'll show you why right here. Remember that h and k values give us the coordinates of our vertex. Well, h isn't here, so it's 0, and k isn't over here, so it's 0. So the vertex is, in fact, 0, 0. And also a unique thing about absolute value functions is that they are symmetric. They have symmetry along the vertex. So if we were to place a mirror straight down there, whatever the line looks like on the right side is going to be reflected in a mirror on the left side. So let's try and pick some other values here. -1, if I put -1 in for x, well, the absolute value of -1 is 1. So we can graph that. -1 to the left, +1 up. Okay, and if we do -3, then the absolute value of -3 is +3. And so -3 up 3. So we start to see something. We start to see a slope over here, and actually if you look for the a, which is our slope, it's not really there, but it's implied. It's implied that a is 1 if it's not there. It's similar to how if we're in a slope-intercept form, looking at a line and a slope-intercept linear equation right here, that this right here is implied that it's 1, right? Even though it's not written, it's still there, and that slope is 1. So very similar to that, right here is in fact an implied 1. So our slope is 1. So if we start at the vertex and we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, we could actually graph this entire side. And remember that it's reflected over this axis, so that's a reflection of that. Here would be a reflection of the other point, and so on and so forth. And so eventually we could draw ourselves, hopefully neater than I just did, the graph of y equals absolute value of x. And this is our base graph, alright? So if we start putting h values and x values, we're going to be moving the vertex of this graph and making it skinnier or fatter, and that's how it's going to affect it all. So again, you could use x, y values. You could always do that no matter what your absolute value function is, and you could get your graph. But if we know what a does and what h does and what k does, then we don't really need an xy table, and we could actually graph a lot faster. So let's try a different example here. Get another graph going. Let's try y equals the opposite of the absolute value of x plus 1. So remember that an implied number right here is 1. Well, if there's a negative, then it's implied that it's -1. So a equals -1, or the slope equals -1. And a negative slope means that we have a line that goes down or falls. So actually, if you remember from what we just talked about, we should have an upside down v. It's going to open downward if a is negative or less than 0. What else could we start off with here? We know that h and k are going to be the vertex. Well, there isn't an h, so that value is 0, but there is a k. It's 1. So our vertex is actually at 0, 1. 0 on the x, 1 on the y is right there. And our slope is down 1 over 1, down 1 over 1, down 1 over 1. And it's symmetrical across the vertex. So we know these are mirror images on both sides. And that's how fast we can graph absolute value functions if we know a little bit about a, h, and k. We could do an xy table to prove it, but I'll leave that up to you. Let's do another example. Let's hopefully get some h values going here. Y equals the absolute value of x minus 4 plus 3. Again, there isn't anything right here, so a is implied to be 1. And h and k now have values. Remember, just this is our h. It doesn't include that negative, so h is 4 and k is 3, so that's our vertex. So at 4, 3, put our vertex. We know it's going to open up because A is positive, and we have a positive slope of 1 over 1, so it's going to go like that. And again, symmetrical across the vertex, so these are mirror images on the other side, these points, just reflections. And there's the graph of this function. Let's talk about a few more things real quick. Remember that this is this graph, but it's been shifted to the right 4, and it's been shifted up 3. That vertex, it started here as this function, but because we added a 4 and a 3 there, we shifted to the right 4 and up 3. Let's try another example. Y equals -2 times the absolute value of x minus 5. So A now is no longer 1, it's actually a bigger number, it's -2, so our slope is going to be -2 over 1. H isn't in there, so H is 0 again. Remember, HK is going to be our vertex, and H is 0, it's not there. But K is now negative, and this negative actually goes with it. So it's -5. So 0, -5 is my vertex. It's going to open downward because A is negative, and it's going to be a slope of -2, 1. -2, 1. And again, reflected over that vertex. And so now we get a slightly skinnier V. It was shifted down 5 from its normal spot at 0, and it now got a little bit skinnier because A grew, or the slope increased, and it was negative, so it opens downward. I think we got one more example. Hopefully it's starting to become clear how to graph these functions quickly and easily without using an XY table. Y equals 3 times the absolute value of x plus 6 minus 2. Here's where it starts to get tricky. A is positive 3, so that's going to be a slope of 3 over 1. It's going to open upward because A is positive. But H, now this is where it gets tricky. H is, we would think it would be 6, right? But remember our form was, let's see if I can write it over here. Y equals A absolute value of x minus H plus K. So if I get a plus a number inside here, well, that must mean that H was negative, because if I subtract a -6, then that gives me an x, right? X minus a negative, that gives me an x plus 6. A double negative is a positive. So that's how we end up with plus 6 in the form. So H has to be -6. And that's kind of the trickiest thing about this. Remembering if H, what actual sign I give with H. So a double negative is what's going to make this become a positive instead of that subtraction sign. So H is -6 and K is -2. So let's find, I almost got in the way here. There's our vertex, and it goes up 3 over 1, up 3 over 1, up 3 over 1, and it's symmetrical or reflects across that. So look how much skinnier it now is, because A is increasing in value. So now I have a much skinnier graph, and it shifted from this location of a vertex, it shifted left 6 and down 2. Alright, so again, if this is too much for you, you can always use XY tables and crunch a bunch of numbers and get an output and be able to plot your X and Y values and get the same graph. But if you know all of these little cheats right here, it makes it a lot faster and hopefully, after a lot of practice, a lot easier.